were electrified times. Luigi Galvani discovered animal electricity by electrocuting a frog to see if its muscles would twitch. They did. Alessandro Volta was busy making what would eventually become the modern battery. Alexander von Humboldt, in all his polymath glory, was doubting electricity altogether, both animal and metallic, while Michael Faraday was revealing how electricity and magnetism were connected. Believe it or not, the common thread running through the work of these fine gentlemen is the electric eel. Over the years, the electric eel has frightened countless horses, inspired scientists, and been the subject of art and music. Scientists recently discovered that this Amazon-dwelling fish, its name is a misnomer, as it's actually a kind of fish. An eyefish, to be specific, is actually 3 different species of fish: the original Electrophis electricus and 2 new additions, E. volti, and D. vari. So, how do these fish produce voltage up to 860 volts? Electric eels aren't the only fish that can produce electricity. There are a host of fish that produce electricity at different capacities. Broadly, there are 2 types of electric fish: weakly electric fish and strongly electric fish. Weakly electric fish like the Peter's elephant nose fish and the black ghost knife fish don't produce enough electricity to shock anything, but it serves as a sense organ, helping them communicate and interact with their surroundings. Strongly electric fish are those that produce shock waves that can harm. The electric eel, a knife fish belonging to the Gymnotidae family, is the most popular of these variety. The electric catfish, the electric ray and the electric stargazer are some other potent zingers. These fish use their electric powers for a range of purposes, from communication and electrolocation to hunting or defense. Electric fish produce their electricity through a specialized electric organ. The electric eel's electric organ, for example, occupies about 2/3 of the fish's body, which is divided into 3 different parts, each producing a different nature of electric current. The main organ and hunter's organ produce the high-dosage electric currents, while the sex organ is responsible for the low voltages. The electric ray has 2 large electric organs on either side of their head. Some might have it in their tails. Within the organ are cells called electrocytes arranged in stacked columns, with multiple columns parallel to each other with fluid-filled spaces between them. Electrocytes are modified cells either of muscle, in most cases, or neural origin. These cells generate the eel's electric punch. The number of electrocytes in a column and the number of columns dictate how much electricity the fish can produce. How the electrocytes produce electricity is fascinating and highly specific. Electrocytes have 2 sides, a posterior side that is innervated with a motor neuron and an anterior side that is undulating and slightly rumpled. Its membrane has many tiny protein channels that selectively allow sodium and potassium ions, different channels for each, to flow into and out of the cell. The signal from the motor neuron causes the ion channels on the posterior side to pump Na+ and K+ into the cell, while the anterior side continues to pump the positive ions out of the cell. This gives the posterior side of the cell a relatively positive charge on the inside of the cell, and the anterior side a negative charge on the inside of the cell. Voila! A dipole has been created and the fish has electricity. What do the fish use their electric powers for? Most electric fish use electricity as a sensory tool, much like sight, smell and touch. For freshwater fish like the electric catfish and the electric eel who live in the murky, dark waters of the Amazon, electricity replaces a sense like sight. The fish send out an electric field through the rods, and receptors on their membranes collect information on their surroundings. These electroreceptors, noticeable in electric eels and electric catfish as pits in their skin, act like voltmeters, sensing the changes in the electric field caused by their surroundings and determining whether something can be dinner. Sometimes 2 electric fish with similar discharge frequencies bump into each other, causing their electric fields to overlap. To prevent interference caused by the two signals, electric fish have come up with a clever mechanism called the jamming avoidance mechanism. The jamming avoidance mechanism is when the two fish will change their discharge frequencies away from their numbers. They collect information based on the other fish's odd, and then change its own accordingly. Neuroscientists have been fascinated by how electric fish are quickly able to respond to their surroundings to change their electric field. Scientists of the past aren't the only ones inspired by how nature has managed to harness electricity. A team of researchers from the University of Freiburg and the University of Michigan have created a soft battery made of a gel-like substance using electrocytes as inspiration. The team hopes that their work can be put to use in certain medical procedures. Electric fish still have a lot to teach scientists about how electrolocation works and how these sparky fish evolved in the first place. There could be even more shocking research revelations to come. Just make sure you don't get zapped in the process.